Okay, so to start, let's remember in Chapter 6, Section 6.2, we did a lot of finding probabilities with our normal calculator. And in that section particularly, all of the problems told us this is a normal distribution in order to get started, and that's how we knew we were allowed to use the normal calculator. The difference between that and what we're doing now is they don't necessarily start out being normal, or a lot of times we don't know if they are normal or not, or at least approximately normal. So what the CLT, what the central limit theorem allows us to do, is it allows us to take samples from any population. Most populations in general in the world are not necessarily normally distributed. They might be skewed, they might be bimodal, multimodal, just any which way. But if we take a sample from these populations, whatever they may be, and if the sample that we take hits these three conditions in the CLT, then what we know is that at least that sampling distribution, not the whole population itself, but the sampling distribution should be approximately normal enough in order for us to use the normal calculator and, trust the results that we're going to get from it. Nothing stops you from using the normal calculator on something that isn't truly normal. You can use it, the answer that it spits out just isn't trustworthy. So what we have to do is we have to make sure that when we're using that tool, we're using it appropriately. So that's what the three conditions are. So a lot of problems require you to check those three conditions. They didn't ask you to check the conditions on this particular problem, but we could. We could go through and we could see, yes, it does say in the problem that the sample is random. We have the n and the p values, right, that are given to us. P being 23%, the sample size little n being 300. So we could calculate, is np greater than or equal to 10, and is n1 minus p greater than or equal to 10, and that would work out. And we could also check, is the population large enough? Is the whole population of candies greater than 10 times 300? So are there more than 3,000 candies made from this company? Of course there are. So we could go through and check those if it was required for us. They didn't make us do that. What they did is they told us, as you can see, I've got starred in red there, they told us we can use the normal approximation for this. So they already checked all the conditions and said, yes, these apply. We're allowed to use the normal calculator for this. When we go to the normal calculator, we have to know what are we going to type in for our mean and what are we going to type in for our standard deviation. So that's what this final part of the central limit theorem tells us. It tells us you're allowed to use the normal distribution, and what you're going to put in for your mean is the p-value, and what you're going to put in for your standard deviation is this standard error formula that we've got. So that's where our work comes in this problem. We have to take this. We know we're allowed to do it at this point, but we have to take this and fill it in. So it's going to be a normal approximation, we're told that, with mean p, so the mean is 23% or 0.23. We have to type those in their decimal format. And then we have to find this standard error. So to find that, we have to take the square root of p 1 minus p, which is 0.77 in this case, over n, which is 300. And if you divide that all out, you should get about 0.02. Let me see, I already did it. I already checked it out. 0243. So that's what goes here. So what we need to do at this point is we need to go to the normal calculator, type this in, and specifically we are trying to find the probability that it will have, the sample will have 26% or more orange candies. So the third thing we're going to type in is what's the probability that we'll have more than or greater than or equal to 0.26, and then it's going to fill in the blank here with the answer for us. Okay, so at this point it's the same as what we were doing in chapter 6. So I already had my normal calculator up. I already put in the mean of 0.23, the standard deviation of 0.0243, find the probability that x is greater than or equal to 0.26, compute that. It looks like the probability is 0.108 rounded to the 3 decimal places. So that's the final answer that we're going to enter, is the 0.108. So again, really the new part, what's different now than in chapter 6, is that sometimes we are required to check these conditions first before we are allowed to apply the normal approximation to a problem. And we're not just straight out told this part, the standard deviation to type in, we have to calculate that instead.